Hey everybody, welcome in. Today we're going to be tackling grade 4, module 3, lesson 2 problem set. And in this lesson, we want students to be able to solve multiplicative comparison word problems by applying the area and perimeter formulas. So that phrase, the multiplicative comparisons, really means phrases such as times as many, or times as long, or like 2 or 3 times as much as. That's what a multiplicative comparison is. And for the purposes of this lesson, we really need to distinguish the difference between length and width. A lot of times what will happen is we'll tell students, oh, the length and width, we could have one side is the length and the other side is the width. It doesn't really matter which one is which. But for the purposes of this lesson, it kind of does matter because we're going to be looking at the length as like the top edge or the bottom edge of a rectangle, and the width being the left or the right edge of the rectangle. And that's going to be really important when it comes to solving some of these word problems. So let's go ahead and jump in. Number 1 says a rectangular porch is 4 feet wide. Now, when it says wide, we're referring to the width. So we know that the porch is 4 feet wide, so we know the width is going to be 4 feet. It is 3 times as long as it is wide. And when it says long, that means we're referring to the length. So again, width is going to be the left and the right edge. The length is going to be the top and the bottom edge. So it says label this diagram with the dimensions of the porch. And this problem can really trip up students if we don't distinguish the difference between the length and the width. So when it tells us that it is 4 feet wide, we know that this edge over here, this left edge, is 4 feet wide. And it is 3 times as long as it is wide. So if my left edge is 4 feet, then this is going to be 4 feet. And I have 3 groups here of 4. So 4 feet here, 4 feet here, and 4 feet here. So this is where we have that 3 times as long. So 3 times the width, which is 4. It says label the diagram with the dimensions of the porch. So we could say that this is, 4, 4, and 4, or we could say that since it is 3 times 4, that would be 12 feet. Letter B says find the perimeter of the porch. So I'm just going to go ahead and real quick sketch from letter A. So this left edge is 4 feet. And since it's a rectangle, the right edge is going to be 4 feet. My top edge is 3 times as long as it is wide, so that would be 12 feet because 3 times 4 is 12. And my bottom edge is also 12 feet. And then to find the perimeter, we would go ahead and add these up. So 12 plus 4 plus 12 plus 4, and I could really add these in any order. So 12 plus 4 is 16. 12 plus 4 over here is also 16. So now we have 16 plus 16, which equals 32 feet. Number 2 says a narrow rectangular banner is 5 inches wide. And again, wide, I should probably do that in yellow, keep things consistent. Wide means the width, and it is 6 times as long as it is wide. And when it says long, that has to do with the length. So draw a diagram of the banner and label its dimensions. A narrow rectangular banner is 5 inches wide. So the width is 5 inches. And it is 6 times as long as it is wide. So for the purposes of my top edge, since it is 6 times as long, it would be 6 times 5, which is 30. Since my left edge of this rectangular banner is 5 inches, the right side is 5 inches. And since my top edge is 30 inches, the bottom edge is going to be 30 inches as well. And now it asks us to find the perimeter and the area of the banner. So let's go ahead and we'll do the perimeter first. So the perimeter is the distance around the outside of this banner. So 5 plus 30 plus 5 plus 30. 5 plus 30 is 35, plus 5 plus 30 is 35 over here, and 35 plus 35 is equal to 70 inches. Now we'll go ahead and we'll solve for the area of the banner. Area is equal to the length times the width. And again, since we're being really consistent with what side is the length and what side is the width, the length would be 30 inches times the width, which is 5. And 30 times 5 is, well, 3 times 5 is 15. And we can bring this 0 along for the ride to make 150 square inches. Since we're measuring the area, the dimension for area is square units, and the units in this case is inches. Number 3 says the area of a rectangle is 42 square centimeters. So this time they're giving us the area off the bat. Its length is 7 centimeters. What is the width of the rectangle? So we can go ahead and sketch out our rectangle. We know the length is 7 centimeters. So the length is going to be this top edge, 7 centimeters. And they also give us the area, which is 42 square centimeters. So that's the measure of the inside amount of this rectangle. So if I plug into my area formula, area is equal to length times width. Plug in what we know. We know the area that was provided to us is 42 square centimeters is equal to the length we know is 7 centimeters, but we don't know the width, which we're going to use the letter W for the width. So 42 is equal to 7 times something, or I could think of this as a related division problem. 42 divided by 7 will give us our width, and 42 divided by 7 is equal to 6. So 6 centimeters is equal to the width. Letter B says Charlie wants to draw a second rectangle that's the same length. So our length is going to be 7 centimeters from letter A, but 3 times as wide. So it was the width, or we're looking for the width. Draw and label Charlie's second rectangle. So we'll go ahead and start with our rectangle. Charlie wants to draw a second rectangle that's the same length. So the length is still 7 centimeters. But it is 3 times as wide. So the width is going to be 3 times the length, which is 7. So 3 times 7 is equal to 21. So if this side is 21, then this side is also 21. And since my top edge is 7 centimeters, the bottom edge is 7 centimeters. And letter C says, what is the perimeter of Charlie's second rectangle? So this drawing is a little bit misleading because my width should be longer. So I should actually probably draw the rectangle more like this, with longer edges along the left and right hand side. So 7 centimeters up top, 7 centimeters down below, 21 centimeters on the right side, 21 centimeters on the left side. And since I'm searching for the perimeter, I can go ahead and add those up. So the perimeter is equal to 21 plus 7 plus 21 plus 7. 21 plus 7 is 28, plus 21 plus 7 is 28. And 28 plus 28, I'll go ahead and do a little bit of side work over here. 8 plus 8 is 16. 2 plus 2 is 4, plus 1 is 56. So the perimeter is equal to 56 centimeters. Number 4 says the area of Betsy's rectangular sandbox is 20 square feet. So they're giving us the area right off the bat is 20 square feet. The longer side measures 5 feet. The sandbox at the park is twice as long and twice as wide as Betsy's. So draw and label a diagram of Betsy's sandbox. What is the perimeter? So we know the area. Let's start with our rectangle. We know the area is 20 square feet. And it tells me that the longer side, and since it says side, we can really think about whichever side we really want to here, measures 5 feet. So I'm just going to go ahead and put 5 feet up here. And we need to first find the width in order to find the perimeter. So if I was to try and figure out this side, I would use my area formula. Area is equal to length times width. The area is 20 square feet, so I can go ahead and plug in 20 is equal to, and we use the length in this case, so we have 5 times, and we don't know the width, so we need to think to ourselves, 5 times something gives me 20, or I can think of it as a related division problem. 20 divided by 5 will give me that missing edge. No matter how you slice it, the width is going to be equal to 4. 4 times 5 gives me 20. 20 divided by 5 gives me 4. So this is over here. And we need to find the perimeter. So perimeter is equal to 5 plus 4 plus 5 plus 4. 5 plus 4 is 9. Plus 5 plus 4 is 9. And 9 plus 9 is equal to 18, and in this case, we're looking at feet is our unit. Now, letter B has to do with the sandbox at the park. So not Betsy's sandbox, the sandbox at the park. And it tells me the sandbox at the park is twice as long and twice as wide as Betsy's. So my rectangle should be a little bit bigger. And we need to refer back to letter A because this tells me the dimensions of Betsy's sandbox. So hers was 5 feet as the length, but it tells me that the sandbox at the park is twice as long. And we see this word twice, that means we're going to multiply by 2. So 2 times 5 and twice as wide, which means we multiply by 2 for my width. So 2 times 4 over here. So 2 times 5 is equal to 10. And 2 times 4 is equal to 8. So my left edge is going to be 8 feet. My right side is going to be 8 feet. My top edge I already know is 10 feet. And my bottom edge is then going to be 10 feet also. And we need to find the perimeter over here. So perimeter is equal to side plus side plus side plus side. So 8 plus 10 plus 8 plus 10. 8 plus 10 is 18. 8 plus 10 is 18 over here. And I'll go ahead and do a little bit of side work. 18 plus 18 will give me the perimeter. 8 plus 8 is 16. And my 6. Carry the 1. 1 plus 1 plus 1 is 3. So the perimeter is equal to 36 feet. Letter B says, what is the relationship between the two perimeters? So let's compare the perimeters from letter A and letter B. Well, I notice that in letter A, our perimeter is 18 feet, and our perimeter over here is 36 feet. So 18 feet and 36 feet. Let's refer back to what we did to the side lengths up here. So we went from 4 to 8 because it was twice as wide, and we went from 5 to 10, which is twice as long. And if I notice, 36 is 2 times 18. So since we doubled every edge from part A over to part B, the perimeter also doubled. So we can go ahead and say that. The perimeter of the sandbox at the park is twice the perimeter of Betsy's sandbox. Letter D says find the area of the park's sandbox using area is equal to length times width. So we need to find the area of letter B over here. So I'm just going to go ahead and real quick redraw that sandbox. Dimensions are going to stay the same, and area is equal to length times width. So area is equal to 8 times 10, and 8 times 10 is equal to 80 square, and our unit is feet. It says the sandbox at the park has an area that is how many times that of Betsy's sandbox? So the sandbox at the park, we already discovered that the area of the sandbox at the park is 80, is how many times, so 80 is equal to something times the area of Betsy's sandbox, which is 18. I'm sorry. Not 18. Nope, that's the perimeter. My apologies, I made a mistake on that. We need to go back up to the problem, and it tells us that the area is 20 square feet. So 80 is equal to something times 20. So 20 times something is going to give us 80. So if we can kind of ignore these zeros for right now, we could think of it almost as 2 times something is equal to 8. So my missing amount is going to be 4. So 20 times 4 is equal to 80. So the area is 4 times bigger. Letter F says compare how the perimeter changed with how the area changed between the two sandboxes. Explain what you notice using words, pictures, or numbers. So in letter D, we found the relationship between in letter C, we found the relationship between the two perimeters, and we said it was twice, or twice being 2 times as much. But my area is 4 times bigger. So we're going to go ahead and we'll put that into words here. We'll say the perimeter, of the, I think it was playground, right? Yeah, the sandbox at the park. The perimeter of the sandbox at the park is 2 times as big as Betsy's sandbox. The area of the sandbox at the park is 4 times as big as Betsy's sandbox. So when we went ahead and we doubled the side lengths from letter A to letter B, the perimeter doubled, but since I multiplied by 2 4 times, that's what made the area 4 times as big.